Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 8th grade topic, adding and subtracting using scientific notation. If you're new to my channel, I'll be putting time codes in for this video in the description box below, so feel free at any point to check that out and skip ahead to whatever part of the video you think is most interesting. If you have any questions about what you see here, anything at all, remember you can always put those in the comment box below. I'd love to be able to help you as much as I possibly can. If you have questions about your own homework that you see on this channel, remember you can visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. When you find this video helpful, remember to leave a like. It really helps this channel get my videos to more and more people who could potentially use some help. And while you're at it, hit the notification bell, smash the subscribe button, and share this video with a friend. Without further ado, let's talk a little bit more about adding and subtracting using scientific notation. Before we can jump into how to actually add and subtract using scientific notation, there's one thing that you really got to get under your belt first, and that's basic understanding of the scientific notation. If you don't have any idea what scientific notation is, this is not going to make any sense to you. So feel free to check out my video on the basics of scientific notation that I'll link up here, and then come back to this video for how to add and subtract it. After you get a basic understanding of scientific notation, the next part you have to worry about or concern yourself with is the form. We can't really get into how to add and subtract without understanding what's happening with its form. Now you might be asking yourself, what form is Courtney talking about? And if you are, kudos to you, good question. I'm talking about the basic form of exponents. So let's say we have something like this, x to the 8th power. And I'm going to put x here because x, I want it to be any number. It could be 1, 2, 3, a million, 10 million, it doesn't matter. I don't want us to just kind of pigeonhole our example to being 10 because of scientific notation. It could be 10, but it could be so many more things. So I'm just going to put a blanket x here. Same thing for your exponent. Exponent could be any number. I'm just going to put a here for simplicity's sake, but I'm going to show you why in a little bit. So this is our basic form of our exponent. We have some number raised to some power. This is the base of our exponent, and this is the exponent. Or sometimes we refer to that as the power of our exponent. And whenever we have a number in front of our setup here, we tend to call that the coefficient. And that's just going to be an m, because once again, m can be any number. I'm just putting some high-level stuff so you kind of see the form. So we have this setup, some number times our base raised to some power of a. But let's say we have another exponent, and it also has a coefficient. And we have x raised to some power b. Same setup, but we have different coefficients and we have a different power, but we have the same base. This is your basic form of your exponents that I'm going to be referring to. Once you understand the basic form, now we can see whether or not we can add and subtract them. So let's say we had this. If we were trying to add, or let's say we were trying to subtract this setup here, this is not going to work. In order to add and subtract something that looks like this, you need a few things. The first thing you need is for them to have like bases. The base has to be the same. If the bases aren't the same, you can't combine them. The next thing you need is to have like exponents. If your exponents aren't the same, you can't combine them. So in order to add and subtract, we need to make sure that our base is the same and our exponent is the same. If those two are the same, you can add and subtract. So in this case, once again, our base is the same, so we can kind of check that off our list. But we see that here as well, our exponents are not the same. Let's do a quick quiz with some actual numbers plugged in. So we don't have our arbitrary coefficients and powers now, but we are going to keep our base as an arbitrary x. So really quickly, by looking at 1, 2, 3, and 4, which ones are we going to be able to do? Not asking you to do it, but which ones are possible based on what we just said about having like bases and like exponents. So when we look at this, is this possible? Number 1, 3x cubed plus 5x cubed. Can we combine those? Yes. That's possible because they have the same base of x, and remember, x can be any number, but because they're both x, they're both the same. And exponent, our 3 is the same, so we can combine it. How about number 2? Just looking at it really quickly, can we combine those? X are the same, yes, but our exponents are not. So this is a big no. How about number 3? Once again, x is the same, but exponents are not. So big no, we can't do that. Number 4, x is the same, and so is our exponent. So we can do that. So think whenever you're doing anything with these kind of base form where you have your exponent raised to some power and you have some number associated with it in front, our coefficient, you can't combine them unless they're the same base and the same exponent. So how does this form relate to our scientific notation? Well, remember I said x can be anything. So for our scientific notation, x is going to be 10. So when x is 10, we have something like this. 5 times 10 to the 5th. But we don't have to write it like that. Another way of writing this is something a little more familiar. 5 times, I know we use that x for multiplication as well, so try not to get confused here, times 10 to the 5th. This is our scientific notation because remember, we need to have one digit, one non-zero digit, and when we do, this is called scientific notation in this form. So going from here to here is really just writing it differently. This x is a multiplication, while that x is a variable. So don't get confused there. That's just what we're using to show multiplication, and that was just what I was using to show it could be any number. I could make that a y, it doesn't matter. Any letter would work. So if this is the same thing as this, that means you have a base here, and you have an exponent here, and it's going to have the same principles of whether or not you can add and subtract. This will just be our coefficient because all we're doing is multiplying by our base raised to some exponent. Nothing is different between this and this. So we got the form down, but we still don't know how to actually add or subtract these things that are in scientific notation. And remember, whenever we don't have decimals specified, it's after your last digit of your number here. And because there's only one non-zero digit before the decimal, this is in scientific notation. So first things first, can we add these? Yes, they have the same base of 10 and the same power. So there's nothing we have to worry about. We can jump straight into adding this, and to do so, all we do is add what I call the coefficients. So you take this, you add them together, and whatever that equals, you place it here. So 3 plus 2 gives us a 5, and then we're just going to bring down this times 10 squared. That's it. That's how you're going to add numbers in scientific notation. If they have the same base and the same exponent, all you do is add the coefficients. Whatever number is multiplied by the base raised to that exponent. Let's look at subtraction. Can we subtract this? Yes. Same base and same exponent. All we have to do is subtract the coefficients. Whatever number is multiplied by the base raised to some exponent. So 9 minus 5 gives us a 4. We bring down the times 10 to the 5th. That's all you have to do. Now what happens when you have different exponents? I previously told you that when you have something like x to the a minus x to the b, you couldn't do that. And that's true because you don't know what that x is. So even if you had 3 and a 2 here, the coefficients don't really matter because you don't know what that x is. But that's a different story when you do know what the x is. And scientific notation pretty much determines what that x is going to have to be. We know for a fact that x in this case is always going to be 10. So when we have scientific notation, but you have different exponents, you can actually still do the math. You just have an extra step you have to do. So going back to 3 times 10 squared plus 4 times 10 cubed. If these were x's, we wouldn't be able to add these because we don't know what that x is. But because we know that they're definitely 10s and they're both the same, we can add this. There's one simple step that we have to do, and once we do that, it's going to be just like you would in every other situation in which you have same base and same exponent. And that is, get the same base in the same exponent. That's your step. If you have them with the same base but different exponents, simply change one to get the same exponent. And because we know what the base is, we can easily achieve this. However, whether you start with this one or this one is going to be a personal preference. I'm going to start with this one. But like I said, it's a personal preference, so you start whatever one you want. I'm going to rewrite this 3 times 10 to the second power, and I'm going to add 4, but I need this to be in the second power. So this is really going to be times 10 to the second power times 10. You see what I did there? I broke this 10 to the third power up into times 10 to the second power times 10. And because multiplication is commutative, it doesn't really matter the order this is currently in. You can kind of combine them in different orders, right? So we're going to combine the 4 and the 10. So I'm going to rewrite this as 3 times 10 squared. And what's 4 times 10? That's going to be 40 plus 40 times 10 squared. So you see, now we have like bases and we have like exponents. And because we have both of those, we can just add like we normally would their coefficients. So this is going to be 3 plus 40, which is just going to be 43 times 10 squared, or times 10 to the second power. But if you want to get this back into scientific notation, you have to do a little bit more, because remember, this is not scientific notation. The decimal is considered to be here. We want the decimal here. And if you remember what we talked about in my intro to scientific notation, whenever you move the decimal here, what happens to your exponent? Well, your exponent gets larger, right? So if we move it here, we're going to pretty much add 1, because we moved it over 1 space to the left. As you go to the left, your exponent gets larger. So the answer for this one is really going to be, I'm just going to put a little box here. This is our answer, 4.3 times 10 to the third power. Now I started on this side, but you can always start on the other side as well. So I recommend you try it on that side and see if you get the same answer that I got. So let's practice on one more example just to make sure we understand what we're doing. In this situation, we have 3.57 times 10 to the 21st power minus 5.19 times 10 to the 19th power. We want to subtract this. Can we subtract it? Well, first thing we have to ask is, do we have the same base? Yes, we do. How about the exponent? Do we have the same exponent? No. So that means we can't just go straight to subtracting their coefficients. However, we know what the base is. So we can do a little bit of work to get the same exponent. And using what we know about scientific notation, we can do the change very simply. So the first thing you want to do here is pick what side you're going to work on. Which side are you going to make look like the other as far as the exponent? I'm going to work on this side. Once again, this is a personal preference. It doesn't really matter. You can do either side. Just make sure you do it correctly. I'm going to do this side. And my goal is to make that 21 exponent convert to a 19. But we don't want to change the value of this, so we have to use something about our scientific notation that allows us to easily change our exponent while preserving the value. And that's shifting our decimal over. In the last example, I showed you that whenever you move it to the left, your exponent goes up. But if you move it to the right, your exponent goes down. That's something we covered in that first video, so if that confused you, go check out that first video I linked up top. However, I'm going to use that fact to easily convert this 10 to the 21st power into a 10 to the 19th power. So if I want to convert this 21 into a 19, I need to move it over 2 spaces. So this 3.57 is really going to look like 357 with a decimal here. And after I do that, I now have my 10 to the 19th power. And I can bring this down because nothing needs to change here, because that's already 10 to the 19. And now we have not only the same base, but the same exponent. So now that we have what we need, we simply subtract the coefficients. So you're gonna do 357 with your decimal, and you're gonna line up your decimals, 5.19. And you're gonna subtract these two. So what's 357, and just for, keep things consistent here, what's 357.00 minus 5.19? Well, this is going to be a 1, this is going to be an 8, this is going to be a 1, 5, 3 here. So your answer is going to have this coefficient. This is not your answer. This is just the coefficient. So after you bring down the times 10 to the 19th, you have your answer. But let's say your teacher wants you to put this in scientific notation. It started out in scientific notation, and you should probably finish it in scientific notation. This is not scientific notation. You have to have at most one non-zero digit before the decimal. This has 3 of them. So we can't say this is scientific notation, although we have it times 10 to some power. So we have to convert this back to scientific notation, and to do that we need to move this over to the left 2 spots. And when we do that, this gets increased by 2. Remember, to the left it gets bigger, to the right it gets smaller. So the true final answer for this is going to be 3.5181 times 10 to the 21st power. So I hope you have followed through the examples, and I hope you understood that adding and subtracting using scientific notation is not that difficult if you understand basic scientific notation and understand the form of exponents. If you can master those 2 things, this process is really no different from your usual addition and subtraction. Of course, if you have any question about what you saw here today, you can always put them in the comment box below. I'd love to really help you as much as I possibly can. If you have a question about your own homework to see on this channel, remember you can visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like. That really helps get this video and many of my other ones to more and more people who could potentially use the help. And don't forget, hit that notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.